The structure of the cutting machine should have a clear idea about forces coming during cutting operation. So prediction of cutting force is important for design purpose also. Now the third and most important point, to maximize the productivity. If you know forces acting on a cutting tool, you can easily predict life of the tool. So you can obtain a balance between life of the tool and rate of cutting in order to obtain maximum productivity. Now we will get into more technical aspect of cutting operation. This is a tool which is performing a single point cutting operation over this cutting edge, and the tool moves in this direction. For an orthogonal cutting operation, tool velocity and cutting edge will be perpendicular to each other, and this is the case we are analyzing in this orthogonal cutting operation. And a cutting force Fc should be there in order to overcome the resistance offered by the material during the cutting operation. If you multiply the cutting force and the tool velocity, you will get the power consumption. But determination of this cutting force is not so straightforward. For that we have to do some more analysis. So let's get into it. A detailed analysis of cutting. Here alpha represents the right angle of the cutting tool. Here we will do a simple force balance on this cutting chip. During cutting operation, this chip flows upwards with the velocity Vc, and during this motion, the chip rubs against the cutting tool. So there will be a frictional force which it has to overcome in this direction, exactly opposite to the direction of motion. If frictional force is present, then there will be a normal force also, orthogonal to the frictional force. So the resultant force acting on the chip will be like this, as a sum of normal and frictional force. And you can determine the friction angle beta if you know the coefficient of friction between chip surface and cutting tool surface. So the resultant force R is acting on the chip on cutting tool side. And what are the other forces acting on the chip? You can see some metal thickness increase from uncut side to cut side. This thickness increase is due to interplanar slip between different metal layers, and there should be a shear force to support that. For simplifying our analysis, we are assuming that this shearing action happens on a single plane, exactly on this plane. And you can determine angle of this plane, phi or shear angle, using a simplified analysis, and this will be the equation for that. Now there should be a shear force on this plane in this direction, and obviously there will be a normal force associating that. If this chip has to be in equilibrium, then resultant of these two forces should be equal and opposite to the resultant force at tool side. So it should be like this. Now we understood what are the forces acting on this chip, but we have to determine direction and magnitude of all these forces. So that's next step. For that we will start from this resultant force side. For this force, obviously you don't know what's the magnitude of that, but you know what's the direction. You can prove that this is an angle alpha minus beta. So you draw a line which is in angle alpha minus beta with the horizontal, and on this line we will attach the shear force. Magnitude of the shear force can be determined in terms of shear strain rate and properties of material, and you already know angle of the shear force, so you will draw a line with the magnitude Fs and angle phi with the horizontal. It will be like this. Now draw a line which is perpendicular to the shear force. It means resultant force line over here. Now you can draw a circle assuming this length as diameter of the circle. So this is it. And this circle will be known as the merchant circle. So this right angle triangle in the merchant circle represents the following forces: shear force, the normal force, and the resultant force R. Now back to the basic question: how to determine the cutting force Fc? We know cutting force is parallel to the tool motion, so what we have to do, we will just mark a parallel line over here, like this. So this will be the magnitude of cutting force. If you draw one more line orthogonal to the cutting force, that will be known as thrust force. So the resultant force of the tool side can also be represented as a summation of cutting force Fc and the thrust force Ft. thrust force Ft physically means the receive force which is orthogonal to the tool direction, and the thrust force is a critical parameter while doing tool design. That is all about shear plane cutting force analysis. Thank you for watching the video.